Hold on. I don't know why it's so slow. But there are three studies that I want to just give you an overview for. And the big, as I said in class, the big issue, or the big thing to keep in mind is that the reason you're doing these studies is to collect data that you can then use to make decisions about what improvements you need to make, right? And that's independent of the project. This is always the question that we have in mind when we're collecting data. And the point is that obviously we're collecting data from for a sample from a population, and we're interested in the population, not the sample. Okay, so volume studies, as you know, we're interested in um, directional volumes, right? So which turns are they making? Which lanes are they in? Right? If there's a multi-lane road in one direction, I want to know how many cars are in each lane. That's can be an important thing. Sometimes we're interested in vehicle classifications. You won't be, other than very minimal. And of course, we're interested in turns. Not only are they coming from north or south, but they're making a left turn or they're making a right turn at an intersection. Sometimes we're interested in vehicle occupancy, which in this case, for your project, you won't be. And then the alphabet soup, and I'll explain these as we go along. ADT stands for average daily traffic. ADT stands for annual average daily traffic. This is the number that comes from those continuous count stations that I mentioned before in class. Okay, so this is the average if you actually observed traffic hour by hour, continuously, 7 days a week, 365 days a year. This is the number. Would be the average day. Okay. The design hourly volume is the hourly volume that you are using for analysis and design. If it's a brand new road and you have continuous counts, this is typically the 30th highest hour in the year. And then, of course, this is on freeways or divided roads. We look at directional design hourly volumes. Okay. So then we talked about this. Volumes vary, right? By month, by day of the week, even hourly. During the day. When we normally collect peak hours, right? We all know this. And then even within the hour, as I mentioned, there's a distribution within the hour that we have to consider. If we have most of the traffic in a shorter period of time than that hour, then that's something that we want to know, right? So monthly can depend on geographic area. Typically, like for example, at a college, the volumes are higher during the school year. Disney World is a great example. There's certain times of year when the roads around there are very heavily traveled, and then other times when they're not as traveled. Daily volumes typically, Mondays and Fridays are a little bit lower sometimes. And then the hourly volumes, of course, right? You have the peak hour volume in the morning and the afternoon, and then there's always a little bump in the middle of the day for lunch traffic. And then within the hour, even, you have a peak hour factor. We talked about this in class, and this is basically just the peak hour volume, that hourly volume that you counted, divided by 4 times the high 15-minute volume that you counted, right? Because you're keeping track of the 15-minute intervals, right? Every 15 minutes you record how many cars there were, right? That's P15. So if all of the traffic happens in one 15-minute interval, then the peak hour factor is at its lowest value, which is 0.25. Okay, so how do we accommodate those? Well, here's an example of a continuous count station. Let's say, and by the way, these count stations have more detail than this. They typically have hourly volumes, or even less, even more finely collected. But let's just say that this continuous count only has daily volumes, right? So we have Saturday, Sunday, Monday through Friday, Saturday, Sunday, Monday through Friday, and so on. And each day we have a count. So if I were interested in finding out how do Sundays compare to the average? Let's say the average overall of all days is 1,250. That's the AADT, that average annual daily traffic. That's the most accurate, if you will, measure. If I'm interested in how Sundays compare, I can take the average count on Sundays from this database. So if I use some data from Mass DOT, count station 5130, and I'll show this to you on the next slide. You should have this in your notes. I want to estimate the ADT. The ADT, remember, is an estimate using data from my sample of the AADT, the big one, right? So I collect my traffic counts on Mondays, and the count is 1,000. And I count it in, I forget what month, I think March I said. Well, that'll be coming. But let's say it's on a Monday, right? So the Monday volume is 1,125. The overall average is 1,250. So Mondays are a little lower, right? They're a little lower than the average. So if I count 1,000 vehicles, that's going to be a little lower than the actual average for the population. So the Monday volume is 90%, in other words, of the AADT. Okay? So I know also I'm going to collect, I forgot to put the month in before, but if we're collecting it in February, I know that the average daily volume in February, I can get that from the big list of days, right? Is 1,820. How's that compare to the AADT? Well, it's 46% higher in February for some reason at this location. So therefore, February volumes, as I said, are 146% of AADT. So if I want to find, I don't want March, I want February. Monday in February. So I know Mondays are 90% of the AADT, and February are 146%. So if and by the way, again, remember this is February. I did it for February. So, but anyway, I can just solve for AADT, and this is the estimate of the AADT, 761. This is the Monday factor from our data, from our continuous count station. This is the February factor from the continuous count station. And table 8-13 has some example numbers for you that you could use. I'll be giving you some for your project. Okay, so there's some things to think about when you're doing a volume count, right? And you can do it manually. We can use tube counts, which we won't be doing. Permanent count stations, as I mentioned, they can either be cameras or other kinds of detectors using advanced technologies. So the primary considerations are, what time am I going to do my count, right? So do I want AM peak, PM peak, or what? What day of the week am I going to do, and so forth. How are you going to lay it out? Who will be sitting in that lawn chair by the side of the road counting the cars, and where will you be situated? What time period? So you typically, as I said, for peak hour, you probably need about an hour and a half or so, overlapping each side of that peak hour. And then you have to decide, well, okay, if it's at an intersection, which is it normally is for a site visit, you have to decide, am I using pencil and paper, or am I using the iPad app, or some other device? And how many people do I need to do this intersection? If it's an intersection like a small one, like you're doing this semester, you probably don't need as many than if you were doing some big intersection in Boston. So here's a turning count sheet that you could use with paper and pencil, and just make your little tick marks. Every 15 minutes you'll have a new sheet, okay? And just make little tick marks every time you see a movement. Or you could just do a simple homemade version of this. This represents each approach, right? And each sheet would be one approach, one 15-minute interval. This is an old style board. It's mechanical buttons. The advantages, there's no batteries. We actually have some of the to the website, or to the computer. The app, I don't think I have a picture of, but it's an app on an iPhone or iPad, and you can it automatically just does stuff for you and puts it into an Excel spreadsheet. So there's some automated methods as well. They're for longer term. Tube counts are, it's a little electronic device that sits on the side of the road. It's got a little tube, a pneumatic tube that goes across the lanes, and every time an axle hits it, it increases the count. Permanent counts, magnetic loops, you're probably all familiar with. We'll talk about these later on in the semester. Cameras, again, we'll talk about these in class later on. So Autoscope is one company, and the original company that made the cameras. So this is one of their cameras, and it actually has software to back it up that will allow you to count cars from a video. And this is an example of a computer screen from the Autoscope software. So you can, as the user, this is a video in the background, you can actually draw virtual little loops that will count cars and measure speeds and all the rest of it. It's pretty good stuff. So intersection counts, the most complex. Counting intervals, they're typically 15 minutes. I mentioned arrivals versus departures. You're counting departures, but what if there's more cars arriving than are departing, right? And that's often the case. Oftentimes we need to keep track of those as well. Just wanted to bring that up. And then, of course, the peak hour determination, you need to figure out what the peak hour is. So the arrivals and departures, if these are the arrivals, and I have departures like this, then I have unmet demand. And what happens? That forms queues, right, lines at the intersections. We're not counting the arrivals by default, but at a very busy intersection we might choose to do so. Okay. So I'm going to go through an example of finding the peak hour and doing the peak hour factors for each movement. Okay. So here's some data. Here's some sample data that you have in front of you, and this is this is more than an hour and a half. It's a couple of hours, 2.5 hours. I want to find the peak hour in these data. So these numbers represent the 15-minute counts from each approach, and here is the total for this 15-minute interval. Starts at 3:30. Okay. Now, if I add these up, these 15-minute intervals, this is the hourly volume from 3:30 to 4:30, 3:45 to 4:45, and so on. Right? And well, you can see the highest hours right here. So that's the peak hour. That's the peak hour. That's how you find it. And so now I have the peak hour. I want to find the peak hour factors, right? Remember, so we'll do this for each approach. So for the northbound approach, the hourly volume is 136 divided by 4 times the highest 15 is 0.85. And for the southbound, 181 divided by the highest 15 times 4, and so on. Okay. So these will be used later on. You'll see where we use these, but this is how you calculate them. And again, you know, if you have continuous count data, you would adjust these numbers, these volume numbers, accordingly. Now, these I had said were 12-minute break counts. That means if you have a complex intersection, you want to give a break to the guy who's collecting the data so that they can, you know, organize papers and so forth. So they collect the data over a 12-minute period and then take a 3-minute break. And then ultimately they adjust the volume numbers up by, so this is 15 minutes, this is 12 minutes, right? So the 15-minute volume would be a bit more than the 12-minute volume. Right? So one could do that. Okay, and then once you're done, here are the turning volumes, and here are the total volume on the approach. These numbers in parentheses are PM volume, so this captures both AM and PM peak hours. Okay, we're going to take a break right now.